Hi everyone, in this video we are going to discuss about block diagram and what are the block diagram reduction rules we have. How to visualize a complex system with many components. We need to visualize a complex system. And second question, how to understand the flow and the transformation of signals in a complex system. And very importantly, how to find transfer function of a complex system. We are going to use a block diagram representation to address these questions. This is the motivation behind a block diagram. What is basically a block diagram? As we all know that a control system consists of many number of components. A block diagram is a graphical representation of the functions performed by each component and the flow of signals. Such a diagram depicts the interrelationship that exists among the components. What are the important elements of a block diagram? One is a block, another one is a branch point, third one is a summing point. Block. In a block diagram, all the system variables are linked to each other through a functional blocks. A functional block is a block or it is a symbol for mathematical operations on the input signal to the block that produces the output. Let us see this diagram. This is basically a block. You are giving an input A, you are getting an output B. The B is nothing but A into G of S. It is a mathematical operation. You are performing some mathematical operation of the input. In this particular block diagram, usually we write the transfer function. Usually we will write the transfer function. So the arrowhead pointing towards the block indicates an input. The arrowhead leading away from the block represents the output. Such arrows are referred as signals. Next we see the summing point. What is the purpose of a summing point? It is used to add two or more signals in a system. You have an input A and input B which are getting added together. That is, here it is performed a subtraction operation, so it is A minus B. A circle with a cross is a symbol of summing point. Next one is a branch point. It is a point from which a signal goes to another block. Here you may have another block or you may have a summing point. This is the branch point. This particular point is a branch point. You have a transfer function G. What is the output? It is nothing but A into G. Block diagram reduction rules. A block diagram reduction rules refers to, or the block diagram reduction refers to, a simplification of block diagrams of a complex system through some rearrangement. In order to do these rearrangement, we have set of rules we are going to discuss. What is the main objective of the simplification? We can easily compute the overall transfer function of the system. This is an example of the block diagram you see here. So this is an electrical system. You are going to compute the Laplace transform of output by Laplace transform of input, that is V naught of S by Vi of S, which we will call it as a transfer function. Now I am introducing the transfer function representing G, or I can say G of S is representing the transfer function. So the transfer function of this electrical network is 1 divided by 1 plus SRC. Usually inside this block we write the transfer function. Let's see the block diagram reduction rules. We are going to see what are the different rules available for block diagram reduction. Totally 11 rules are available. First one is combining the blocks in cascade, that is series. You are having an input A passing through the G1 block, you will get AG1, and passing through the another block G2. So totally the output is A times G1 G2. Whenever the two blocks are in series, you can multiply their gains or the transfer function. This G represents the gains or transfer function. When the blocks in cascade, the gains has to be multiplied. When the blocks in parallel, you have to add the gains. A input, AG1, AG2. If you add it, AG1 plus AG2, if you take A commonly, it is G1 plus G2, which is equivalent to input A. You can add these two gains. Next, moving the branch point ahead of the block means that here you have a branch point. You are shifting this branch point after the block. Means you have to divide by the gain. Rule 4. Moving the branch point before the block. Here you have a branch point. You are shifting the branch point before the block. Then you have to multiply by the gain. Next, moving the summing point ahead of the block. Here you are having a summing point. You are moving the summing point after the block. Then what we have to do? We have to multiply it with the gains. The logic is multiply with the gains. Next, moving the branch point, moving the summing point before the block. You have a summing point. You are moving this summing point before the block. You have to multiply by the gain. Interchanging the summing points. It is possible to swap these two summing points. For an example, A is an input, C is another input, A minus C. Then you are adding this with B. You will get A minus C plus B, which is equal to A plus B minus C. This is also possible, interchanging the summing points. Next one is splitting the summing points. That is possible. You can go for splitting. You have a 3 inputs, A, B and C, A plus B minus C. This you can divide into a 2 summing points, A plus B. Then you can subtract it with C. So it is A plus B minus C. This is splitting the summing point. Likewise, we can combine the summing points. If you are having such a summing points you can bring together with a single summing point. The output is a plus b minus c. This can be replaced by means of this particular blocks. Here there are two important block diagram reduction rules which are essential to eliminate a feedback loop. There are two feedback loops. One is a negative feedback loop, another one is a positive feedback loop. You can see here you are giving an input or we have a feedback that is taken from the output. The feedback output is C. We are representing the output is C passing via the feedback. The feedback is represented by H, CH. So you are subtracting R minus CH multiplied by the gain, it is R minus CH into G. This is your C. This is what I have written. C is equal to R minus CH into G. You are multiplying G inside, RG minus CHG, bringing this C term to the left and take C outside. If you find the output by input, output is C, input is R, so C by R, it is G divided by 1 plus GH. That is what written inside the block, whereas an input is an R, output is a C. G divided by 1 plus GH. In case of the positive feedback loop, it is G divided by 1 minus GH. These are the block diagram reduction rules which are useful while solving a complex block diagram. These are the references. Thank you.